Hello, tonight our video is on the topic of similar figures. Similar figures are figures that we get when we take a figure and we dilate it. In other words, we increase the size or the lengths of the sides or decrease the lengths of the sides. So here we have an example of two triangles that are similar. Okay, they're the same shape and the angles should be the same if we measured them. And the slopes of the sides are the same. But what's different are the lengths. The lengths have changed. This triangle DEF, is bigger than triangle ABC. So if we go over here, we can see a better picture of that. So here, angle A is congruent to angle D. They're the same measurement. B and E are the same angle measurement, and C and F are the same angle measurement. So we would call them corresponding angles because those are the angles that are going to stay the same. They don't change when we dilate a figure. All right? And then the slopes of the sides are still going to be the same. Okay, this slope here is the same as this slope. But what has changed are the lengths. It looks to me like this shape has doubled in size. So side AB is increased from 10 to 20. AC is increased from 7 to 14, and EF is increased from 6 to 12. Okay? All right, so the only thing that changes with similar figures are the lengths of the sides. And we'll get back to that in a minute. Now, these right here, these are not similar. These are congruent. Okay, congruent figures are those that are exactly the same size and shape. So if we were to take, this triangle and we were to spin it around, okay, we can match up the 65-degree angles, match up the 75-degree angles, and 10 would still match up. This is the same shape, it's just rotated around. Okay, so those are congruent figures, not to be confused with similar figures. Congruent figures are the exact same shape. They haven't changed in size. And that's what we used in our rigid transformations. But in our dilations, we use similar figures. All right, so here are two similar rectangles. Notice that the angles are all 90 degrees. They haven't changed. Notice that the slopes are the same. CD is a slope of 0, so does HG. AC is an undefined slope, so does EH. Okay, so slopes and angles are the same, but what has changed are the lengths of the sides. And similar figures are what we say proportional. So when you have similar figures, you can use a proportion to find the lengths of the missing sides. Okay, so let's do that. Let's use proportions to find CD right here. All right, so how I would do that, I would take the known sides. Here I have 6 and 16 on the small one. So the ratio of 6 to 16 on the small rectangle should be the same as the ratio of 30 to CD on the larger rectangle. And I always replace that with an X. And I can solve that proportion for X. All right, well, I can see from my proportion that I'm just multiplying by 5. Okay, this 30 is 5 times more than 6. So if I multiply 16 by 5, that would give me side CD. So that's going to equal 80. All right, and since they're rectangles, then I know that this side is also 80, this side is also 30, this side is 16, and this side is 6. All right, let's try another one. All right, here we have two similar triangles. Notice that they both have the same right angles. These acute angles are the same measurement. Okay, so it appears that this triangle ABC is twice as big as DEF. All right, so again, I can use a proportion to set this up. I want to find side EF, so I'll call that X. Okay, so I can say that 13, the ratio of 13 over 12 on the large triangle should be the same as x over 6 on the small triangle. So I can see that the smaller triangle is half the size. Right? So that means x would equal 6.5. All right, and then this side here, side AB should be twice as much as side DE. So 2.5 times 2, this side over here is going to equal 5. All right, here's another one. Go ahead and find the missing sides. Find side GF and side EG. Pause your video and restart to find your answer, or check your answer. Welcome back from pausing the video. All right, I can see that the corresponding sides on my similar triangles, this side 4 corresponds to this side, 28. So it appears that this triangle, the lengths are 7 times as much. All right, so that means I can go 5 times 7, and that would give me this side, 35. And I can go 6 times 7, and that would give me this side, which is 42. And of course, I could set up a proportion like I showed you before to be formal about it. 4 over 28 is going to equal 5 over x. Let's say I've called this x right here, side GF. And I can cross multiply and divide to find my answer. But again, I would still get the same answer, 35. And I can just see that it's 7 times greater. So really, even though they are proportional, you don't always need to set up the proportion to find the answer. You can just multiply if you know how many times bigger the shape is. These are similar figures. Find x and y. Pause your video and then restart to check your answers. Welcome back from pausing the video. I can see from this side here, I can see from this side and this side that this second figure is twice the size. So the multiplier is 2 times. So to find x, I can take 3.6 and multiply by 2. I really don't need to set up my proportion. So 3.6 times 2, that means this side must be 7.2. Okay, and then by using the same logic or reasoning, I know that side y on the smaller figure is half the size of its corresponding side on the larger figure. So I can take 3.2 and divide it by 2. And that would be 1.6. Okay, so y is going to equal 1.6 centimeters, and then x is 7.2 centimeters. So how'd you do? Did you get it right? Okay, try this next one. Find the length of x, pause your video, then check your answer. Welcome back from pausing the video. All right, so this one we're not going to be able to multiply like we did on the previous ones. We will have to set up a proportion because it's not so easy to determine what our multiplier is. First things first, I do want to understand that this angle corresponds with this angle. So if I was to rotate this shape around, okay, and face it the same direction as the larger shape, those angles would match up, and that means that the 5 on the larger shape corresponds to 3.5 on the smaller shape. All right, so the smaller shape, we have 3.5 centimeters, and the corresponding side on the larger shape is 5 centimeters. All right, on the smaller shape, I have 8.4 centimeters, and that corresponds to x on the larger shape. So now I can solve my proportion by cross-multiplying and dividing. So 8.4 times 5, that's going to equal 42, and then 3.5x. Now divide both sides by 3.5. So cross multiply and divide to get our answer. All right, so 42 divided by 3.5, that comes out to equal 12. All right, so this side equals 12. How'd you do? All right, well, that's all for tonight. Thanks for listening. Remember, read some books.